Okay, hello everybody. I just want to walk you quickly through homework number 5, which is about t-testing, and it's due a little over a week from now. I'm still waiting here for your homework number 4s to come in, but right on its heels, we got another one about t-testing, which hopefully will not be as involved R-wise for you, but will still involve a fair amount of thinking. So yeah, let me just give you the basics. So for the first, there's 3 questions. Each one you will apply a different t-test. And for the first one, what I want you to do is run one sample t-test, and we're going to do it looking at the original VOT data set that I collected the first time I taught this class 10 years ago. So I'm just going to show you where these things are, looking through the course webpage here. So in homeworks, we've got homework number 5 here, which looks exactly like what I was just showing you in the video. And that's in the same spot. The data set that we're going to play around with for question number 1 is the 2011 class VOT, and I've got it up here in 2 spots. Like I said, so I mean, the reason this one is different from the VOT data sets I've collected since then is that I had the students produce both aspirated stops and unaspirated stops in English. So P's and B's, T's and D's, K's and G's, that sort of thing. So an initial position in a word like beer or gear or so on and so forth, these what we think of as voice stops tend to be just unaspirated. Maybe they're voiced, maybe they're not. Your job is going to be to run one sample t-tests for each of the 3 places of articulation for the unaspirated stops, so the B's, the D's, and the G's. And then for each of those places of articulation, determine what the probability is of the true mean of the population being equal to 0 milliseconds. So I'm not going to run the test for you, but just like looking through here, right? So some of these unaspirated stops have negative VOT, meaning that they're genuinely voiced. Others have like 0 VOT, so it seems like it's a live possibility that the overall mean might be 0, because some of these as well are positive, like this one has a VOT of 90 milliseconds. Okay, we don't know the answer, but what I want you to do is just run 3 different one sample t-tests, one for the bilabial, alveolar, and velar places of articulation, and determine what the probability is of the true mean of the population being equal to 0 milliseconds. Report the results of your t-tests in the standard format, and I've got some guidelines on that below, and then clearly state the conclusions you draw from the results of each of these tests. So I want to walk you through this instruction specifically because down here on the bottom of page 2, I've got the guidelines for reporting t-test results. So when you run a one sample t-test, we've seen this in the lecture, you get a big batch of results that look like this in R, and what you really care about is on this line. So what you want to report is the t statistic, the number of degrees of freedom, and then the p-value that you get out of that. So what it will look like when you actually report it in your write-up for this homework is something like this. Sorry, I don't know why it's doing that, but this is t, and then in parentheses degrees of freedom, and then the t statistic here, and then the p-value. If you get a very small p-value, like less than 0.001, just put p less than 0.001, so on and so forth. You don't have to like write it all out in scientific notation or anything like that. Please just kind of abbreviate it. Again, one of your jobs in writing up your results or answers to these questions is to make it easily digestible by a knowledgeable reader, basically, which is, in this case, me, but it should be anybody else who knows how to run statistics out there. With that in mind, kind of the most important part of the whole process is what happens after you get that p-value. So you get a p-value, like in this case, it's 0.002. In this case, it was looking at aspirated VOT. I can't remember the exact example. It doesn't matter. In this case, for this homework, what you're going to do is you're going to get 3 different p-values, right? One for each of the 3 different places of articulation when you're trying to determine is the true mean of the VOTs of those different sets equal to 0 milliseconds or not. You get a p-value out of running the process of a t-test that reflects on this question. The last thing you have to do in this exercise is answer the question. So don't just tell me what the p-value is. Don't just report the results of your test. Tell me what it means once you actually get that p-value. Otherwise, you're not telling me anything, really. So that's why I've bolded this instruction throughout, because people, for some reason, have missed this part of the process over and over again throughout the years. Like I said, I've been doing this for a while, for 10 years. Give me an answer to the question. is the true mean of the population of these VOTs equal to 0 milliseconds or not? Okay, you will find that out by running these t-tests, or you will be able to make an educated guess as to what the answer to that question is by running these t-tests. With that in mind, we'll do something similar for question number 2. We'll do a little research, so-called. We're going to go back to the VOT data set for this class, and I've got this in 2 forms here. So this is the original, no, sorry, we're not going to look at this anymore. This is the original VOT data set that we were playing around with at the start after we did homework number 1. I've also got it kind of expanded with the same data here for question number 3 with these format measurements and the F-zeros and so on and so forth. You can use either one because it's the same VOT data set in both cases in this column right here. But either way, what I want you to do for this one is to run paired samples t-tests instead of one sample t-tests. And I want you to determine whether the following samples of data are significantly different from each other. So number 1, I want you to look at VOT for stops between 2 different vowels. So there are a lot of stops produced next to the vowel E here, or the vowel A, or the vowel A. There's 5 different vowels, right? Just pick 2 of them and tell me whether the VOT is consistently different between one vowel and another. I'll let you figure out how to do that. The second question, or question B, is VOT for stops from 2 different speakers. So you can say pick Summer versus Isabella, or Charles versus Elizabeth, so on and so forth, whatever. Just match up 2 different speakers and then tell me if their VOTs are different from one another. And again, I want you to run paired samples t-tests here because there's multiple variables involved here. So there's 4 different, actually I guess just 3 different variables: speaker, stop, and vowel, and we'll get to stops here in a second. And then there's one kind of dependent measure here, VOT. I guess you could also use repetition, but we're not going to do that yet. Anyways, these all match up, right? So Summer produced the exact same set of words that Isabella produced with the exact same set of vowels, and she produced them 3 times, so on and so forth. So you can pair them up exactly and run one of these paired samples t-tests to answer this question. And the third dimension, or the third variable that I want you to look at, which I just talked about a second ago, is the VOT for stops from all 3 places of articulation. I want you to compare them pairwise against each other. So there are 3 different places of articulation. There's P, there's T, and there's K, or there's bilabial, alveolar, and velar stops. So you'll be making 3 comparisons there, right? P versus T, P versus K, T versus K. Got it? So you're going to, in total, run 5 different paired samples t-tests for this question on the homework. And then once you're done with those, you report the results of your paired samples t-tests in the standard format, like down here. And then also tell me what they mean. Clearly state the conclusions you draw from the results of each t-test so that I know what they mean with respect to the data that we're playing around with here. Okay, that's it for question 2. Question 3 is basically the same idea. We're going to use a different test though, and we're going to actually run more tests. So we will, for this one, play around with these normalized format measurements and also the regular format measurements that we started off with, that we played around with a couple of homeworks ago. And so I want to walk you through. So this is where the data set is. It's online. You can get it through the data sets link here as well, down here on the bottom. So for the first part of this is that I want you to run 2 sample t-tests on the format data. So remember, we have 5 vowels, and we've got 2 format measurements for each vowel. So that gives us a total of 10 measurements, basically, that we can play around with. And what I want you to do is compare them between the male and the female speakers. So we're kind of doing what we were doing before when we were normalizing the plots, just when we were trying to graph the format measurements before. But here we're going to compare male and females to see if they're significantly different from each other. And remember, we have differing numbers of female speakers and male speakers, so they're not going to be exactly paired up with one another. We're going to have a bit of asymmetry there, but that's okay. You can still run these t-tests on the data. So to start off with, for example, are the female F1 values for E significantly different from the male F1 values for E? That's your first t-test. And then for the second one, you'd say, well, how about female F2 for E? Is that significantly different from male F2 for E? And then you move on to the next vowel A, you do F1 and F2, so on and so forth. And ultimately you run 10 tests in all, 10 t-tests in all. They're all 2 sample t-tests. And again, there's 5 vowels and 2 formats for each vowel. That's how you get to 10. Report the results of each test in the standard format and clearly state the conclusions you draw from the results of each test. Now, there's 10 tests here, so you can have a lot of reporting to do. If at the end you want to sort of just combine the results in an overall conclusion from what you found out, that's fine to sort of make it more efficient that way. But at some point, you have to tell me what the results of the test actually mean with respect to this data we're looking at here. Similarly, we're going to do basically the same thing for Part B, but the only difference here is that you will run the same t-tests with the normalized F1 and F2 measures for the speakers, right? And these were normalized by speaker, but we're coming up with like the same sort of scale basically across the board for all of them. We plotted them in a graph. We're just going to now look at, well, are the normalized F1 measurements for females different from the normalized F1 measurements for the males, so on and so forth. Exactly what we did with the raw ones, but now with the normalized data. You run 10 tests, 2 formants for 5 vowels, and then you report the results of the tests and tell me what they mean. In addition to that, I want everybody to answer these questions after they're done with question 3B here. How do the results of these tests differ from the ones you ran in Part A? Which set of tests do you think tells a more meaningful story about the differences between male and female vowels? Yeah, we talked about this a little bit already with homework number 3, but I want you to think about it again now that we know a little bit better how to analyze these sorts of differences between format measurements using t-tests. There's also a deep thought question for the grad students. So for question 3, you've run 20 different t-tests. Given that you have set your value of alpha to the conventional 0.05, how many false alarms would you expect to get out of those 20 t-tests? Do you have any reason to think that any of the significant results you got in your tests constitutes a false alarm? Why or why not? Okay, I can't answer those questions for you, but I just want to draw your attention to them so you don't forget to answer them when you write everything up and send your answers to me via the Dropbox on D2L. That is what you have to do for this homework assignment. Hopefully it's all clear now, but if it isn't, you can always send me an email or visit during office hours as usual. Yeah, I'm always here in cyberspace. So I hope to see you there or then at some point, but this is due next Friday, so don't forget about it.